Lesson 8.8 is on graphing linear inequalities. Essential question for this lesson is, how are linear inequalities different from linear equations? We have worked on linear equations up to this point, how to graph them, how to find solutions, how to find solutions for the set of or systems of linear equations. Now this lesson will learn graphing linear inequalities, and the way that you work on this is very similar to linear equations, but using the inequality signs either less than, greater than, or less than, equal to, or greater than, equal to signs. Unlike linear equation, the graph of a linear inequality is going to have a region of the coordinate plane bounded by a line, and every point in the region is going to be the solution of the inequality. So you're going to shade parts of the graph to indicate that any of these points can be the solution for the inequality. One thing that you'll have to be careful with this inequalities is when you are drawing the line for your inequality, if it's less than or greater than, you're going to have the line or the graph represented with dotted lines or dashed lines. And then if it's either less than or equal to or greater than equal to sign, you're going to have a regular line without the dash line. So let's go ahead and work with some examples. First question, let's graph this inequality where your y is going to be greater than 2x plus 1. First, you're going to graph the inequality as if it's an equation, y equals 2x plus 1. Because this is an inequality with greater sign with a y, you're going to put dash line instead of solid line. So using the slope and intercept form, my slope is going to be 2 and y-intercept is going to be 1. So I start my point at 0, 1, and then I go up 2 and right 1 for the slope 2 over 1, and connect those 2 points with a dashed line. After I work with the dashed line, my second step is to test a point that is not on the boundary line. So let's say we test 0, 0 in the inequality. Okay, so it's not going to be from the line that we worked with, and plug it in. So y is going to be 0 and x is going to be 0. So the inequality is going to be 0 is greater than 2 times 0 plus 1. Then when you work with the equation or inequality further more, it's going to be 0 is greater than 0 plus 1, and 0 is greater than 1. Now 0 is not greater than 1, so this is a false statement. So since the inequality is false for 0, 0, the shaded region will have to be on the left side that does not contain 0, 0 as part of the plane. So you can shade the left part, and that's going to be the solution for the linear inequality in this case. Let's go ahead and practice a little more because I know this lesson can be very confusing at first. So we have an inequality with y is greater than equal to 3x minus 1. So first step, I am going to graph this as if it's y equals 3x minus 1. So I am going to start from my y-intercept, which is going to be negative 1. And my slope is 3, which means I can change that into 3 over 1. So I'm going to go up 3 and go right once. Once I find my 2 points, I am going to draw the line, and because this has greater than or equal to sign, I can use a solid line instead of the dashed line. And my second step is to check the point to see if it's going to be shaded on the left side or shaded on the right side. So you can really pick any of the points. I'm just going to go ahead and pick 0, 0 because I realize that my line is either containing 0.0 or 0, 0, or not. You can really choose any of the points from the coordinate plane, either on the left side or the right side of the graph. So if I do that, I have y is greater than equal to 3 times x minus 1, and that's going to be 0 is greater than equal to 3 times 0 minus 1, which will then be 0 is greater than equal to negative 1, which is going to be a true statement. So I am going to shade the region where you have 0, 0 as part of it. So again, my left side is going to be shaded for this graph. For my second graph, y is less than 2x minus 4. I am going to do the same thing. So first step, I am going to graph it as if it's y equals 2x minus 4. So I start from negative 4 for my y-intercept, and then I have 2 as my slope. So I move 2 up and 1 right. And then because this one has less than sign, I am going to draw my graph using dashed line. After I connect those 2 points and have the dashed line, I am going to plug in a number to see if it's going to be shaded on the left side of the graph or the right side of the graph. Again, I'm just going to use 0, 0 to see if this graph is going to make a true statement. So 0 is less than 2 times 0 minus 4. When I do that, it's going to be 0 is less than 0 minus 4, which is negative 4, and it's not going to be a true statement. So I cannot shade the area with the part that contains 0, 0. So I have to shade the right side, which will not contain 0, 0 as part of the region. The next part, we're going to learn how to solve systems of linear inequalities. So in the previous lesson, we have learned how to solve system of linear equations, which means you'll have to find a solution that will satisfy 2 of these equations to be true. For the linear inequalities, you'll have to find a region that is going to satisfy both of these inequalities. And for this one, you'll have to solve it using graphing. And you're going to solve these by graphing 2 of these inequalities on the same plane. And you're going to see the overlapping part for the solutions. So let's say we have the system with y is greater than equal to x plus 1 and y is less than 2x plus 3, and using graphing. So first, I'm going to graph y is greater than equal to x plus 1, which will start from positive 1 for the y-intercept and just go over up 1 and to the right 1 unit. And because this is going to be greater than equal to, it's going to be solid line. For the second graph, y is less than 2x plus 3, you're going to have 3 as the y-intercept, so you start from there, and then your slope is 2, so 2 over 1, you go up 2 and 1 to the right. And then because this is less than inequality, you're going to use dashed line to connect those 2 points. After that, you're going to see which of these parts are going to satisfy your portion of the inequality. So for example, the first one, I'm going to use white and color the parts that's going to satisfy the answer. If I put 0 to check, it's going to be 0 is greater than or equal to 0 plus 1, which is not going to be a true statement. So I'll have to color the parts that's going to be on the left side of the graph because that's a part without 0, 0. And then for the second part, I'm going to use yellow, and I will put 0, 0 again. And this time it's going to be 0 is less than 2 times 0 plus 3, and 0 is less than 3. So I'll have to shade the right side of this graph. And you'll find the portion that both colors will overlap, and this small triangular section is going to be the solution for these two inequalities, which means any points that you have in between those two triangles can be the solution of these linear inequalities. Let's have a practice to solve a system of linear inequalities again, so we can be sure to understand this. Let's say we have a set with y is less than equal to negative 2x minus 5 and y is less than 1/2 x. First, I'm going to graph both of these inequalities on the same plane. And my first inequality will be starting from negative 5 for the y-intercept, and it's going to have a negative slope, so I'll have to go down a little bit more. So I can go down 2 more and 1 to the right, and I would connect them with a solid line because this one has greater than or equal to sign. For my second one, I'll be starting from 0, 0 because I don't have any y-intercept given to me other than that. And from the center or the origin, I am going to have 1 unit up and 2 units to the right. So I'm going to connect those 2 points with a dashed line because this is going to be just less than sign. And once I graph them, I'm going to see which parts are going to be overlapping. So once I plug in 0, 0, my first inequality turns into 0 is less than equal to negative 2 times 0 minus 5. 0 is going to be less than equal to negative 5, which is not true. So you're going to have to shade the area that is going to be on the left side. For my second inequality, because it's from the center, I'm going to find a point that is not going to be 0, 0 and randomly plug it in. I would like to use perhaps, let's see, 2, 0. So I would put 2 for the x and 0 for the y. So it's going to be 0 is less than 1/2 times 2. When I do that, I am going to have 0 is less than 1, which is going to be a true statement. So I can shade the right side of the graph that contains 2, 0. Now, when you shade both regions, you're going to find the bottom side here that overlaps for both of these inequalities. And whichever points that you find in that little section will be part of your solutions. For your homework this lesson, you're going to work on page 448, and you're going to have questions 4 through 12 even, 16 to 20 even, 38 and 40. A lot of these questions are going to be using graphing. So if you have a graphing paper, that'll be the best way. But if you don't, you can just draw the graph something like this just to show me which parts are going to be overlapping. Make sure you show work to check which parts that you have to shade and how you decided. And if you have watched this video all the way through, please write the time that you worked on your assignment for some extra credit.